morning, students. Once again, I welcome you to my video lectures on signals and systems. I was going through the properties. The first property was linearity property. The second property was reflection, time reflection. Next, the third property was shifting, time shifting. And now the fourth property I am taking up, what is known as multiplication by an exponential sequence. Xn is the function which is getting multiplied with an exponential sequence. Alpha to the power of n is called as exponential sequence. And sometimes this alpha may be negative. Now, if you know x of z for time function x of n, then alpha to the power of n x of n, its z transform corresponds to x of z by alpha. We have to replace in x of z, we have to replace z by alpha. Then, what about ROC? The ROC, it gets multiplied with mod alpha. Why mod alpha is given? So, in case alpha is negative, then we should not take minus sign here. So, mod of a negative number is a positive number. So, this is the statement of the property. Now, I will prove in one line. First, alpha to the power of n, x n, let z transform of alpha to the power of n, x of n is equal to summation n equal to minus infinity to plus infinity, alpha to the power of n, x of n, then z to the power of minus n, z to the power of minus n. Next, now I will rewrite this n equal to minus infinity to plus infinity, x of n, then alpha to the power of n. So, when it goes to the denominator, it becomes alpha to the power of minus n, z to the power of minus n, alpha to the power of minus n. That is summation n equal to minus infinity to plus infinity, x of n, z by alpha to the power of minus n. Now, this form is familiar for us, this definition of z transform. So, this is nothing but x of z by alpha. Now, to illustrate this property, I will take up this problem. Find z transform of half to the power of n u of minus n, half to the power of n u of minus n. Now, u of minus n is getting multiplied with exponential sequence, half to the power of n. Now, we are not in a position to remember u of minus n, but what we remember is z transform of step sequence. So, u of n, its z transform is given by z over z minus 1, and ROC is mod z greater than 1. Mod z greater than 1. This is for u of n. Now, I will come to this. Now, next, I will use reflection property. U of minus n is u of minus n. So, z transform of half to the power of n, u of minus n. Now u of n is the z transform is given by z minus 1. U of minus 1. Now, reflection property is wherever z you replace it by 1 by z. 1 by z, 1 by z minus 1, or 1 by, take z in the denominator, then 1 minus z. 1 minus z. So, u of minus n is equal to 1 over 1 minus z. And earlier z was greater than 1. Now 1 by z is greater than 1, or mod z less than 1. This is 1 over 1 by 1 minus z. Now I will apply the multiplication by exponential sequence property. Then what is z transform? Now I know what is u of minus n. Z transform of u of minus n. 1 over 1 minus z. Now z transform of half to the power of n u of minus n is given by x of z by alpha. X of z by alpha. So alpha here in this case is alpha equals half. Alpha equals half. Alpha equals half. Therefore x of, wherever z, replace it by z by alpha. Z by alpha is half. Therefore it becomes 1 over 1 minus 2z. 1 over 1 minus 2z. Now, from this also you can find ROC. What is ROC? 2z mod z less than 1, or mod z less than half. Mod z less than half. Mod z less than half. This is how you have to work out this problem. First, take u of n, use reflection property, then you apply multiplication by exponential sequence property, and this is how you have to work out. So this is one answer, this is another answer. In the next class, I will take up the other property. Thank you.